What's up, everybody? How's it going? Today is the day. This is the video, the long-awaited Pathfinding Visualizer project tutorial. This is by far and away the most requested video that I've had. If you haven't seen the video that I made about a month ago on the software engineering projects that got me into Google, where I showcased my Pathfinding Visualizer project, be sure to check it out. I'll put the link in the description and the comments below. But ever since I posted that video, I swear I've been getting multiple comments every single day on all of my other videos asking me for a tutorial for this Pathfinding Visualizer project. This is it. You have asked, you have requested, you have demanded, and as you know, I am a public servant. You demand, I provide. By the way, while I would definitely encourage you to watch this entire video, I do realize that it's pretty long, so I'm going to put timestamps in the description and in the comments below, so that if you want to skip to more important parts, you can do that. Before we jump into the coding, I have to say a few things. First of all, I have no idea how to do this project right now. I wrote the code for this Pathfinding Visualizer 3 years ago, at the very beginning of my coding career. I had only been coding for about 2 or 3 months when I did this project. And if you go on the GitHub repository for this project, which is public, by the way, it is absolute spaghetti code. You'll see that this was written in pure native JavaScript, meaning no libraries like Angular or React, just JavaScript, and of course HTML and CSS. And just overall, it was kind of all over the place, which is fine. I was a beginner, but the point that I'm trying to make here is that I'm not going to be walking you through that code. We will be referencing it to kind of inspire ourselves and see what in the heck I did. You know, I'll probably take some animations, a bit of code here and there, but overall, I'm going to be rewriting this from scratch using the programming knowledge that I know today, and we're going to be doing this in React. Now, if you don't know React, don't worry about it. This is going to be very, very basic React, and I'll even show you how to set up the project, which is super trivial. I just did it now with the Create React App plugin or whatever command it is. And you're going to be able to learn React along the way. And again, this is going to be very basic React, really nothing to fear, and I'm going to kind of walk you through it. The second thing that I wanted to say before we start coding is what exactly we're going to be building in this video tutorial. Because if you look at my current Pathfinding Visualizer project, you'll notice that it's pretty big. There's a lot of functionality. Right here on the home page, we've got this little dialog box that explains what the project is. It's got like 9 pages and a bunch of text and images. We're not going to be doing that. Then here we've got our main grid with a start node and an end node, and you can draw walls on the grid. Of course, you can visualize here 7 or 8 algorithms. You can also draw mazes and patterns. You can add a third node. You can do things like clearing the board, clearing the path, changing the speed of the algorithm, and you've got this little legend here. So again, as you can see, there's a lot of stuff. We're not going to be doing most of it. We are going to be doing the fundamentals, the stuff that you really need to then be unblocked to add whatever functionality you want to do. So what does that mean? We're going to build the grid, of course. We're going to build the start node, this little arrow, and the end node. And I guess we'll see as we go along if we build out the ability to move them, probably, because that's kind of core to the app. But maybe we'll leave that as an exercise to the viewer. And then we are definitely going to build building walls, and we are going to do Dijkstra's algorithm. Dijkstra's algorithm is sort of the grandfather of pathfinding algorithms. That's the algorithm that we're going to implement. We're going to implement the animations, so this stuff. Visualize Dijkstra's. Of course, we're going to do the visualize button. And then finally, we will do the part that actually draws out the shortest path, like this little yellow thing here. I don't think we're going to do this automatic recomputation of the shortest path when you drag the target node. That'll probably be an exercise for the viewer. But the point is, once you have that core functionality of just visualizing Dijkstra's algorithm, you can pretty easily add other algorithms, add other functionality to clear the board, reset it, and so on and so forth, and you can put your spin on it, make this your own project. Third thing that I wanted to say is that the reason I've been sort of pushing off doing this video is because this video takes a little bit more effort and time and concentration than most of my other videos. Like I said, I have no idea how to do this project. I'm going to try to do it right now, but also I'm extremely busy. I've got tons of stuff with AlgoExpert. This weekend I'm traveling, unfortunately, so I won't be able to do much of this at all. So all this to say, right now, I am giving myself the challenge that I have to do this tonight before I go to bed. Now, it is currently 9:58 p.m., and I have not started coding, so I will not stop until I finish the code. I won't edit this video tonight, but until I finish this entire coding tutorial, I will not go to bed. So wish me luck. I've got a Red Bull with me. Again, Red Bull sponsor me. If you haven't seen my previous video, I mentioned that already. Anyway, gotta do it. Last thing before we get into coding, I am preemptively hoping that you will find this video very informative and enjoyable to watch, and the only thing that I ask of you in return for this video is that you be so kind as to smash the like button. It really helps with the YouTube algorithm, and also, if you can, comment down below what you think about the video. That also helps with the YouTube algorithm. The more engagement, all those things, they really do help. Oh, and also, if you're prepping for coding interviews, check out algoexpert.io, use the promo code CLEM, C-L-E-M, for a discount on the platform. That's the sponsor for this video, my company. Now, let us begin. And don't worry, there are going to be links to the GitHub repos for this project that I'm doing in this video, as well as my original Pathfinding Visualizer project in the description and in the comments below. Alright, the first thing we're going to want to do is to get our React app environment set up. Now, fortunately, React does this for you. It's literally trivial to get your first React app set up and running and to just start coding. Just Google create a new React app, click on, I think, the first link. It'll bring you to reactjs.org, and if you scroll down here, it explains to you what you have to do. You need to have Node and NPM installed. Make sure that you have the correct versions. They literally tell you here. And then literally copy paste this line. I just did it. npx create react app my app. You put it in your terminal. I just did it here, and it'll take a while to run. Then you can cd into my app. This will be the name of your directory. By the way, you can name this anything. I named it my app. You probably want to name it like Pathfinding Visualizer. And then finally, do npm start, and you will literally be up and running. Once you've done these things, you should have your directory here with a bunch of files that they've created for you automatically. And then if you go back to your browser, you should have at localhost port 3000 this page that they've rendered for you, and you can make edits to your code. So for instance, here I'll put, see where it says learn React, I'll put learn React foobar, save, and it'll hot reload it. And you can see that it says Learn React foobar. And so now, I guess we're ready to start. So I think I'm going to go ahead and start cleaning up some of these files because we don't need everything here. Okay, so what I went ahead and did is I said I'm actually not going to really touch all of their files because I'm not sure if you need them and I don't want to waste time with that. But I deleted everything that they were rendering in the main app.js file. And I created my own component, my Pathfinding Visualizer component, and I imported it and rendered it here. And now I'm never going to touch their files anymore. I'm no longer going to touch their app.js. I'm no longer going to touch any of their auto-generated files. I am just going to work out of this Pathfinding Visualizer component or directory, which I created right here in the source directory, and any subdirectories or whatever that I want to add in there. So my Pathfinding Visualizer component right now is just this simple React component. By the way, for those of you who are familiar with hooks and functional components in React, I'm not going to be using that here. I'm just going to be using basic React. I think it'll be a slightly more accessible to most people. So here, this is a simple component, right? Pathfinding Visualizer, and I'm not doing anything. It doesn't have any state. It just renders a div that says foo, a node component, and this is another thing that I just created here, node, and I haven't really put anything yet. And I've created a couple of CSS files. So this right now looks like this, a blank page that says foo at the top. So if we go back to our Pathfinding Visualizer, what are we trying to create? Let me clear the board here. We want to create this grid, right? Before we can actually do any of the functionality, we need this grid on the table or on the page. Now, I forget what I did to create this grid. I actually think that I used HTML table elements, but I'm wondering if we can just use like divs that we kind of align one by one. I'm going to play around with the code and get back to you in a bit. Okay, so just to explain a little bit what I'm doing here, I've been trying to see if I can just like have this two-dimensional array of all the nodes and kind of iterate through all of them and render a bunch of this node component, which is going to be right here, which is going to be each little grid or cell. But this just seems like it's not working. I think I'm going to try to go with a table component or a table HTML element and go with that. I think this is what I did in my previous project, so I'm going to go look at the GitHub repo and see if I can figure it out. Actually, I don't think I need this. I think I can go with my original strategy. I'm so bad at CSS, I can never remember how to put shit next to each other. How do you center a div again? This will have to do for now. So what I have so far are just a bunch of nodes that I've kind of like very naively created here with, 15 rows and 50 columns each, and then I iterate kind of through every row and through every column, and I create a node, and that's how I get this grid like this. But, I mean, clearly I'm going to have to clean it up. So I guess I've got my grid here now. I mean, this code is like kind of bad right now, but it does give me what I need. So what should I do next? Maybe I'll start by actually visualizing with CSS the start node and the end node, and then I'll jump into Dijkstra's algorithm, I guess. What I think I'm going to do is I'm going to create a sort of structure or interface for what a node looks like. And I think a node will have a few things. It'll have like a row and a column. It'll have maybe an is visited property. So we'll see as we go. I'm going to get rid of this little React warning here by adding this key property. If you have this little warning, you have to add a unique key to things that are in an iterable. Okay, so I just installed a Prettier, which will auto-format my code because it's so annoying to have like React with huge lines and your JSX not formatted. So if you want to do the same thing in VS Code, just get Prettier as an extension. You can look for extensions with Command-Shift-P. You look for extensions, install extensions, look for Prettier, install it. And then if you go to Workspace Settings, and you look for format on save, make sure that this is checked off, this little thing. And so then when you go to your file, here, you see here, if I have this line and I save it, it auto formats it. Okay, let's keep coding. I've added a start node and an end node. They look very ugly right now, but basically what I did is in my Pathfinding Visualizer, I set the start node and the finish node here in, like, I've created this object. I'll probably have to move this around soon, but I created this object for every node where I say, hey, is start is only true if the row is number 10, so we're on the 10th row, and we're on the 5th column, and is finish is the same thing except if we're on the 45th column. And then down here, when we render these nodes, I pass down as properties is start and is finish based on the node. So we're only ever going to have two, one is start and one is finish with the way the code is written. And so then in my node component, I've got this ternary here, it's a little bit ugly, but whatever, that says, hey, if we have is finish, that's true, we're going to have an extra class name called node finish, and that's just background color red, hence the red node here. And if we are node start, then we're going to have background color green. Okay, so I'm still debating what to do next, but I think I'm just going to go and implement Dijkstra's algorithm and then kind of take it from there. Start marking nodes as visited and so on and so forth. So first, I have no idea how to do Dijkstra's. I forgot how the algorithm works. I can like vaguely remember it, but what I'm going to do is I'm going to look at the code that I had in the previous project. So I'm going to go look at the GitHub repo and I'm going to copy paste it, clean it up, and see if we can work from there. Here it looks like it is in, I think it's in browser, in Pathfinding algorithms. you see, this is why it's bad to not name files like correctly. Like, what is test algorithm? Why is there one that's A star but there's no Dijkstra? I think Dijkstra is in unweighted search algorithms. Ugh, how am I supposed to find this? This is like not comprehensible. Okay, let me go back. Let's see where I called Dijkstra's algorithm. So it's probably in board. Like, look at this code. This is just like incomprehensible. By the way, this goes to show you, I remember I used to be the kind of person who was like, no, I'll remember my code like in the future. It's fine if it's like a little bit crazy. Like, I remember it, I wrote it. Like, no, I literally have like zero recollection of ever writing this. Or no, I do remember writing this, but like understanding this is another story. So it looks like it is this unweighted search algorithm and we pass the current algorithm. Let me see here. Oh no, Dijkstra is weighted. Dijkstra is a weighted algorithm, because let's see, if we have here, if we add weights, if you press W, by the way, fun fact, if you press W and you drag, you can add weights. These, like, the path can go through it, but they count as, like, tougher to go through, if that makes sense. They have a weight. Oh yeah, it is, yeah, I say it right here, it is a weighted algorithm. Yep. Whereas an unweighted would be something like, in breadth first search, we said is unweighted, which means that if I clear the board and if I put, oh yeah, I just can't put weight nodes. I just did not put, like, you can't press W and put a weight node. Okay, now I'm starting to remember. Dijkstra's algorithm is a weighted algorithm, meaning that if there are certain parts of a path that you tell the algorithm, I do not want to go through that part of the path because it is weighted. As an example, oh, there's heavy traffic in this area on Google Maps, right? Dijkstra's algorithm can use that information to compute the shortest path. This is all starting to like come back to me after like 3 years. It's crazy. Okay, so Dijkstra's is a weighted algorithm, and we say if weighted algorithms, so if current algorithm is bidirectional, A star, we do some random stuff. If weighted algorithms includes current algorithms, oh my god, this code. We do this weighted search algorithm. Okay, so we need weighted search algorithm. Boom. Is there a Dijkstra here? Whoa. That is a lot of code for Dijkstra's algorithm. Wait, am I in the correct? Whoa. Okay, let's just copy this entire code. What is going on here? Weighted Manhattan disk. Okay, we're not going to do weighted Dijkstras for now. We're going to do, Jesus, it's 10:54 p.m. already. Okay, so I just created this algorithms folder, which is not going to be like React components, so I moved it out. I kept it in source. Well, who cares about that for now? And in it, I created this Dijkstra.js file, and now I copied this weighted search algorithm that I had, and we're going to try to like cut out all the junk and just like create Dijkstra's algorithm. Once again, I currently don't remember how Dijkstra's algorithm works, so I have to like refigure it out, and once I have it down, I will explain it to you. By the way, as I'm filming this video right now, I'm really hoping that this is going to turn out a good video and not some like garbage, because right now I just feel like it's this camera filming me for like what seems like an eternity, struggling to write CSS, so let me know if you think this is a good video or if this ended up being like really bad. So I think I remember how Dijkstra's algorithm works now. I just want to verify it on Wikipedia, just read an actual explanation rather than try to refigure it out from my code. Okay, I think I remember now how Dijkstra's algorithm works. Basically, you start at your start node, and you kind of forget about your target node for a second, and you say, every other node on the graph, in our case in this grid, right, is going to have a distance of infinity to our starting node, or is going to have a score of infinity, if you will. But that score represents the distance from the starting node. And then you say, okay, I'm at my starting node. I'm going to grab all of its direct neighbors. So in our case, it's going to be up, right, down, left, because we're not going diagonally. And in the case of like a real graph, like maybe if we're in a city or whatever it might be, you know, roads that you can go by or go through or something. But for us, we grab all of our neighbors and we update their distances. For our neighbors, they're at distance 1 from our starting node, right? And you say, okay, now I'm going to pick the closest of my neighbors. You pick one neighbor, and then you update the distances of all the others. Okay, I'm going to write the algorithm and then explain it in detail once we're there. Okay, so I think I've got a working Dijkstra's algorithm. Now, I'm not really going to go too far into explaining how Dijkstra's algorithm works. I'll walk you through the code very quickly. Basically, we have our grid that we take into the function. We've got our start node and our finish node. We start by saying, hey, let's just make sure that we're not in a weird edge case where there is no start node or finish node or where they overlap. But then the idea is this with Dijkstra. You set the distance of every single node to infinity, because you cannot reach all the nodes. They're all sort of super far away, except the start node. The start node is at a distance of 0. And then you say, I'm going to pick the closest node of all the nodes to visit next. Now, of course, if all the nodes have a distance of infinity except the start node that has a distance of 0, then you're going to start at the start node. Once you get to your closest node, the start node, this is what happens here in this while loop, you say, I'm going to update, or first of all, I'm going to visit this node, but then you say, I'm going to update all of the neighboring nodes of this node, in this case, the nodes right above, below, to the right, and to the left, and I'm going to say, these nodes now have a distance of whatever my current distance is, plus 1. So you update all of them, right? So you can imagine, again, in our grid, it's like we had all of our nodes that were at a distance of infinity, except for our starting node at a distance of 0, and suddenly you update the 4 neighboring nodes to be at a distance of 0 plus 1. And then you say, okay, the node that I was just at, I visited it now, and I'm going to eliminate it. And now you say, I'm going to grab now the closest node of all the remaining nodes. Now again, all of them are at a distance of infinity, except 4 of them that are at a distance of 1. So you pick one of the 4, and you keep doing this process. Now, the beauty of Dijkstra's algorithm is that if you use correct data structures, you can get a very fast algorithm. Here, I'm actually not using the correct data structures. Typically, in this thing of keeping track of whatever the closest unvisited node by distance is, you usually use a min heap, a heap that keeps the minimum values, right? And I don't want to do that here because it's not really going to affect, the JavaScript speed of our project. We're dealing with very few nodes, so I'm just using an array of unvisited nodes, and I'm sorting the array every time. So like every time that you're about to explore a new node, you can see that I'm sorting all of the unvisited nodes based on their distance, and then I'm saying the closest node is the one that's like right below here. But overall, typically you would use a heap. And so finally, eventually you will reach a point where the closest node is the finish node, and at that point you're done with the algorithm. So this is sort of the Dijkstra's algorithm that I've got here. We're going to test if it's working with the animations. I haven't handled things like the wall or things like the animations. We're going to do that in a little bit. So unfortunately, my screen recording got messed up for this next part. But basically, all that I did is I added the Visualize Dijkstra's Algorithm button. This is literally just a button with an on-click handler that calls this Visualize Dijkstra's method, which I coded out a bit later. And then I also did a bit of refactoring in this file. So I added this method to get the initial grid. I also renamed the nodes in our state to be grid instead of nodes. It's just a little bit more accurate. And here I also created this create node method that takes in a column and a row and adds a bunch of property that we might need later on in the algorithm. So for instance, I added this distance property, which we need in the Dijkstra's method in the Dijkstra file. I realize that I'm sort of merging UI logic with algorithm logic here, but I figured for this project, whatever, I wanted to kind of move fast, but so that's what I did. Oh, and I created constants for the rows and columns of the start node and of the finish node. And the last thing that I did here in this part is, in the Dijkstra's algorithm, I made this method return an array of visited nodes in the order that we visited them. So basically, after every closest node, I just append the closest node to this array of visited nodes in order. And finally, at the very end, when we reach the finish node, I return this array. And this was done because we're going to want to animate the nodes in the array in the order that we visited them in. So that's what this is. And that's all that I did in this part. I've been spending the last 10 minutes trying to understand why I had this bug where my closest node was equal to 1,000, which just made no sense. And it's because I'm doing unvisited nodes dot unshift, and unshift adds a value to an array. I wanted to shift the value to pop it off from the front of the array. Yep, now it works. Okay, so it looks like we've got our visited nodes in order now from Dijkstra's. Let's assume that we have no bugs and see if we can animate them. This is an array, an ordered array of the nodes that we visited in order. So I'm just gonna iterate through them, and with some sort of asynchronicity or a set timeout in JavaScript, I'm gonna change the state, every 0.5 seconds on each node and see if it animates them. And of course, in the node component, we'll have some kind of if is animated, change the color, or something like that. Okay, so basically where I'm at right now is we click on the button, we call visualize Dijkstra, which calls our Dijkstra's algorithm, which gives us the array of visited nodes in order, and then we call this animate Dijkstra function that goes through all the nodes that we visited in order, and that says, hey, for every node, we are going to create a new node off of that node, and we mark that one as is visited, and then we update our state, which is our grid, with that new node. So we literally do a copy, a slicing of the state of the grid. I know this is not very good from a complexity point of view, but we update the state, and then we say, with a set timeout of 100 milliseconds, with a delay of 100 milliseconds, we are going to, oh, but wait, they would all be delayed by 100 milliseconds. The idea is with a delay of 100 milliseconds, we update the state with that new node as visited, which is going to re-render everything, and we pass for every node the isVisited property, and then in the nodes we say, oh, if we're visited, then we add another class, nodeVisited, which is going to have background blue. But again, this is actually going to bug out. This, if I'm not mistaken, is going to cause all of them to appear blue at the same time. Let's just try. I hope my computer doesn't crash. Okay, so my computer is crashing, but for a reason that's completely different. I'm not sure why. Okay, so what I said would happen did happen. They all turned blue. Why is my computer laggy? Okay, they all turned blue, and this looks like the Dijkstra shape that we should be getting. Okay, we're good, we're good. So now basically we need to delay the set timeout, multiply 100 milliseconds by the index of our current node. So we'll do something like oh crap, I forget closure. Is this not gonna work with the multiplied by I here? It is, with let, it is, right? I think this should work. Okay, let's try it. Nope, it did not work. Why doesn't it work again? I mean, are we sure it doesn't work? Yeah, it doesn't work. Why doesn't it work? I should probably put everything in the set timeout. Ah, there. Now it works. Okay, but this is way too slow, so we'll go back to this. Look! Would you look at that? We've got our Dijkstra's. Let's make it faster. Let's put 50. Let's put 20. What do I have for my animations here? And whatever, I'll just play around with it. Hey, I don't want to say anything, but we got it working. Okay, it looks like it bugs out if you go too fast. Let's do like 15. Why does it bug out here? Is it because of the way we're updating the states? Maybe 20 makes more sense for now. I think the way that we're updating the state is really, really bad right now because we are, I'm probably gonna have to refactor this. We're doing just like so many state updates that have to re-render so much stuff. How could I do this better? Okay, so I was thinking while I was eating that I'm actually not going to refactor the state or the shape of this component for now. I'm going to move on to the next thing, which is making the walls by clicking and dragging across the grid. And then at the end, if we really need to, we'll refactor. But let's move on to the walls. So unfortunately, there was another bug with my screen recording for this next part. It's the last time that it happened. I swear the rest of this video is not messed up. But so here, all that I did was implement the functionality to create walls on the grid. So when you click on a node, you want it to turn into a wall or turn back into a normal node if it was already a wall. And then when you click and drag, you also want to be able to create walls. That's what I did. To do that, I created 3 mouse event listeners: an on mouse down, on mouse enter, and on mouse up, which I call here in the node file on the node div. And on mouse down happens when you press your mouse button, not when you release it. That's on click. On click is when you press and release. On mouse down is just when you press, which is what we want to create a wall, right? We want to just press and have it be a wall. Then on mouse up happens when you release. So on click kind of merges mouse down and mouse up. And mouse enter is kind of just like hovering above an element. Whenever your mouse sort of enters the element's area, this event listener gets called. And so this is going to be useful when we drag our mouse, right, to create the walls. Now, these event listeners here, or these methods, these callbacks that we're calling on the event, are defined in our Pathfinding Visualizer file. And they're pretty simple. The handle mouse down event gets a new grid where the node at the given row and column, we have this helper down here, but the node right here, but the node at the given row and column gets toggled between a wall or not a wall. And it also sets this Boolean mouse is pressed to true because we're going to want this Boolean because in our mouse enter, we only want to make nodes that we enter walls or not walls if we're currently pressed, right? You can imagine that we don't want to hover all the time and make walls. That wouldn't make sense. We only want to click and drag to make walls. So that's why we have this Boolean. And then handle mouse up says, hey, once you release, the mouse is no longer pressed. And we're no longer going to want to create walls. So these are the 3 mouse event listeners that we have. This is what allows us to create walls. And the last thing that I think I showed you in this section was that even though we had created the walls, we weren't actually handling them. So if I look at the grid here, which might look a little bit different than it did in the video because this is sort of the final project here. So if I put walls here, and I visualize Dijkstra's, it's going to kind of just go through the walls and ignore them. All right, back to the normal video now. There, we got the walls working. It's as simple as adding if closest node is wall, continue in our Dijkstra's function. Now I think we need to handle the case where we cannot get to the last node. Yeah, that is buggy. So what we need to do here is we need to do if closest node dot distance equals infinity, meaning if we have literally no closest node because we are trapped in a wall, then we return, what do we return? We return the visited nodes in order. There. So now we stop. Okay, so we're getting really close to actually being done. We definitely need to make the styles a lot better, and I do want to kind of try to make it faster, because right now it's still pretty slow. I'm wondering if we're not going to be able to make it faster because of React. Like, if we set state, can we set state every 10 milliseconds? Yeah, I'm afraid that we might not be able to do this with the React, with set state faster than 20 milliseconds. It seems like otherwise it just like freaks out, because I think, it's trying to re-render the entire DOM. I'm trying to think if there's a better way to do this. I'm gonna put a pause on that for a second, and I'm gonna try to make this a lot prettier by actually adding legitimate styles and animations. Why is the animation causing a bug? The animation is like causing it to be pressed still. You see that? That's so weird. Why is it doing that? Ugh, I hate when they're like incomprehensible CSS bugs. Yeah, it's like continuing. Like, I'm not clicking right now. Like, look, I press up, I click. And it's like it's still clicked. My mouse up? Are we mousing up? Okay, so look. Whoa! What? Look, it's like, look. Like, can you see this? Like, look, press, and it didn't mouse up. It didn't mouse up. Why did it not mouse up? Ugh, no. Okay, I'm probably not gonna fix this CSS bug tonight, because, like, I don't know what this is, but that should have moused up. That seems like some kind of animation problem with React or something. Yeah, we're gonna keep the walls to this color for now, but we're not gonna do any animation on them, unfortunately. Kind of mad about that, but whatever. Whoa! Okay, we're gonna have performance problems with React. So I'm a little bit upset. Well, first of all, okay, CSS animations of this type, when they're this many, can be pretty bad if you are not like on a gaming computer. I used to be on a gaming computer with my previous pathfinding project. Here I'm on a Mac now. So even here you can see, by the way, like, it's pretty laggy when I visualize. It used to not be laggy at all. That being said, this is like exacerbated because of the React state shit. Okay, I'm gonna try doing something very hacky. Okay, let me first try to clean up a little bit of the code and then see if we can do something hacky to kind of circumvent React. This is so weird. Why is the grid getting like morphed? Okay, so the border was what was messing up the grid. All right, I hacked React, everybody. Lo and behold, hacked. So the reason it's no longer laggy is because instead of updating the state in React in the set timeout every 20 milliseconds, which was causing the entire DOM to re-render, or rather this entire like React component to re-render, which was like the entire grid every 20 milliseconds. Instead, what I'm doing is something that you should never do in React, which is I'm grabbing the individual element. And to be honest, I could be doing this with a ref. So actually this is fine with a React ref. Okay, it's like fine-ish. And I'm just updating the class of the element to node visited, and it works. Now let's see with the animation. Nice. Not bad. Not bad. There's something missing though. Like here I have like a yellow dot. See how I have a yellow dot which is like where the algorithm is currently at? I'm not really sure how I was doing that. I think it's this thing. It's like, I had it somewhere. Yeah, visited start node blue animation, I think. Ugh, I don't think I'm gonna get into that. That's like a minor detail that like if you really want to have the node that you're currently at have a different animation. You can probably put like a different class on it or something for a split second. You can probably figure it out. I will leave it as an exercise to the viewer. But look, I'm happy we got it. Like, this is looking pretty close to this, give or take. Oh, look. Nice. Oh, and we can make it even go faster now. If you make it go faster, it starts to lag a little bit, but that's just because of my computer. I can't really do anything about it. If you want to use CSS animations, you have to expect some lag, but cool. So what are we missing now? We've got the walls. Unfortunately, they don't have an animation, but who cares? There's some weird bug with that, like on mouse up with the animation. I'm not going to get into that. If someone knows what that bug is, then do let me know in the comments below, but otherwise, whatever. We've got the actual Dijkstra's algorithm working. Oh, we need to have the shortest path. I think that's like the last thing that we need. Okay, so how are we going to do this shortest path thing? How do we even know the shortest path from Dijkstra? What is this code? Oh, I was keeping track of a previous node. Okay, that is a hacky. And the people demand I provide. Smash the like button. Yeah, so in Dijkstra's algorithm, you need a pointer to the previous node or to the parent node, so it's actually not hacky. It's sort of hacky like in the code, and it's certainly in my old repo, but basically once you arrive at the destination node with Dijkstra's, you have to like work your way back in linear time to find the shortest path. Oh, let's do it. Okay, so my current strategy is I basically renamed the update neighbors method in Dijkstra's to update unvisited neighbors. So I'm only getting the unvisited neighbors, and I've re-added the visited mark here, where when we explore a node, we mark it as is visited. Get unvisited neighbors is exactly the same, but at the very end, it filters the neighbors by those that are unvisited. And then, when we're updating the neighbors with a new distance, we mark them with the previous node that is the current node that we're at. And this should eventually give us the shortest path. Even when we update a neighbor from multiple different nodes, maybe, this should work. And so then, once we have the visited nodes in order from Dijkstra, we can call another node to get nodes in the shortest path order, starting at the finished node and making our way back, right? And so I wrote this method. This really is just like traversing our way backwards through these .previous node. This feels like a linked list, basically. This is really like quite the algorithm that we're writing here. Now, I want to console log it just to see that it's not broken, and then we're going to try to visualize it. So, okay, let's just confirm that it's not broken. Okay, doesn't look like it's broken. Otherwise, we would have gotten... What am I console logging here? Should remove these console logs. Okay, but it looks like it's not broken. Okay, let me just redo it once. Ooh, I hope I'm not going to run out of battery. Let me just redo it once. Okay, yeah. So 21 nodes. This looks sort of correct. And they're all in the same row. Perfect. That means that that's good, because like if there are no walls, it's normal that the shortest path is going to be on the same row. Row 10, perfect. I think we are golden. Okay, animate Dijkstra. And after we animate Dijkstra, where do we go? We want to finish all this for loop. And what do we do? Okay, we can do less than or equal. Okay, this is really hacky. Less than or equal to visited nodes in order.length. And here we can say set time. We can say if, what are we doing? If I is equal to visited nodes in order.length, meaning we are done with all the other set timeouts, then we can do something and return. We'll return here, so we don't have the set timeout. And here we'll do set timeout. Animate, we'll do, it's going to be 10 times I still. This is very hacky. And we're going to animate, we're going to call another animate that says this.animate shortest path, right? Animate shortest path with, this. Okay, this is really gross, but we're going to pass this here, we're going to pass this here, we're going to pass this here. At this point, I just want to get this over with. We are going to call this method here, and it takes in nodes in shortest path order. And here we are literally going to do something like, I guess it's going to be very similar to this, right? So it's going to be another for loop, except here we're going like this, not equals. We'll remove this if statement. We don't need to do any of this. I don't think we need to do any of this here anymore either, because we're doing our document.getElement. So yeah, I'm going to remove this. This can just go away. This can just go away. Beautiful. This can just go away. Beautiful, beautiful, beautiful. This can go away. And here we're going to do not visited, but shortest path. And we will do that. We will have that be yellow, like we had it in my project. So let me see. Oh yeah, there's a bug. What was the bug? Node is not defined. Whoa! That brings you VS Code. You can click that and that brings you VS Code. Whoa! Okay, ready? Please. Please. Okay. Yes! Okay, let's put walls. Let's see if this works. If this works, I'm probably gonna call it, because I'm really happy right now. It works. It should probably be a little bit slower. Let's put this to 25. Let's put a wall again. Wall, some walls. We did it. We got the Pathfinding Visualizer working. And we can probably make that, again, even slower. But okay. What I think I'm going to do now is try to clean up a tiny bit some of this code, because there's still some, like, nasty stuff. And then I'm going to read through all of it to really do the sort of like tutorial part of this video. Probably going to spend just 5 minutes, because hopefully you've been sort of following. And then we're going to call it. Okay, I actually think that this isn't that bad, so I'm going to probably like stop the whole refactor thing here and just like go through the example now, because this works. The algorithm works. It looks close enough to the project that I had for something that I did in what? When did I start? Did I start at 8 or 9? I forget when I started, but roughly like 5-6 hours ago. And yeah, so basically we did this very simply, and I'm very happy that we did this a lot cleaner than my previous project. Like, of course, this is much simpler of an app. I don't have all the other algorithms yet, all the mazes and all of that, but still, this is a lot simpler. We did this with a total of 4 files, basically, minus all the React app stuff, and these files are pretty simple. We've got our node component, which is really the sort of simplest or dumbest component. All that it has is these 3 like mouse handlers, and these are really just for the walls. And these are passed down from the parent component, the Pathfinding Visualizer component. We also have a few like booleans that help us determine what class to put. To be honest, this isn't super pretty here. We could do this like another way, but I feel like it's fine here to just like compute the class name right here in the component. Like there's an argument to be made that we could pass down this string here, like instead of is finish, is start, is wall, we could pass down like type, finish, type, start. But I don't know. One thing to note is we do have to put an ID here if we want to very easily access this node with document.getElementById. I do think that we could use a React ref here, but I didn't really want to spend the time to do that right now. You can Google React refs if you're unfamiliar with them. They're basically like the React way of doing document.getElementById. And that's our node component. Our CSS is very straightforward. The animations, by the way, like they look super fancy, but they're really nothing that special. Like, you could just play around with like all these properties that I have here, just play around with them, Google other types of animation timing function, and see what looks cool. Let me know if you manage to make your pathfinding algorithm project look a lot cooler. No idea why the wall animation was messing up the on mouse up event, whatever. Dijkstra's algorithm here, or this file with Dijkstra, is pretty straightforward. We run our Dijkstra's algorithm. I've added a couple comments for you to make things a bit clearer, but overall Dijkstra's algorithm is all about basically assigning a distance to all of the nodes in your grid and having these distances start at infinity except for the starting node at 0, and saying at any point in time, what is the closest node to me? Typically this is done with a min heap to be very performant or optimized from a complexity point of view, time complexity point of view. Here we just do it with an array of unvisited nodes that we keep sorting every time. And whenever we visit a new node, we mark it as visited, and then we say, okay, well, now that we're here, let's update all of the neighbors to see which one is the new closest, and that's that. And we also keep track of the previous the previous node that we were at. Then we have this get nodes in shortest path order that backtracks from the finish node back to the starting node to get the shortest path. And then finally we have our main file, the Pathfinding Visualizer file. Pretty simple again, it keeps track of our grid in our state. We initialize it at the very beginning. You can read our pure function here that initializes it. It's basically just like hard coding the number of rows and columns that we have and creating nodes out of all of them. And our nodes are structured here. They have like a column, they have a row, they have, a distance, is visited, these kinds of things. They have a pointer to the previous node, so they're kind of like a linked list. And then we've got our functions that handle the mouse events. Pretty straightforward. You can kind of read them. They should read kind of like English. Basically, when the mouse is down, we make sure that we update the mouse pressed to be true, and we toggle the node's is wall status. Same for the mouse enter, but only if the mouse is already pressed, meaning that we're dragging, the walls. And then when we click the button to visualize Dijkstra, we have this animate Dijkstra function. Or first we call the Dijkstra method, right? And passing in the grid and the start node and the finish node. And then we animate Dijkstra. And to animate Dijkstra, we grab the return value of Dijkstra, which is the visited nodes in order. We do this little set timeout thing where we say, like, every 10 milliseconds, animate the node. And to animate it, we don't use React, because typically with React you would just like update the state and that would update all the components, but that becomes really bad performance-wise because we have to re-render the entire grid every time. By the way, there might be a better way to do that with React that I haven't thought of. Like maybe there's a a better way to just update one part of the React component, but I didn't give it much thought. So I just went ahead and did this document.getElementById where we say, hey, for every node, every 10 milliseconds, just change its class name directly in the DOM. Much better from a performance point of view. And I think you could do this with React refs, like I said. And then once we're done with all that, like when I is equal to the end of visited nodes in order, right? Then we do the same thing, but we animate the shortest path this time. And that's literally like the same kind of logic, except here we update the class to be shortest path, which is that yellow thing. And we do it a bit like slower. Maybe this would be 50. And that's it. This is our Dijkstra project. Again, very like bare bones right now. And I will leave it to the viewer to leave it as an exercise to the viewer to do better than this, to really expand it and make it your own, right? You can add so much more functionality, but that's that. Hopefully you found this helpful. If you're genuinely interested in putting this project on your resume, I'd really encourage you to spend a few more days refining it, adding more functionality, more algorithms, putting your own twist on it so that it doesn't necessarily look like an exact clone of mine, but so that it looks like, your own project. Oh, and also there are a lot of edge cases in this project that I haven't handled at all in this video. Like, for instance, not allowing the user to add walls or to move the nodes when there's an algorithm in progress or an animation in progress. So these are the kinds of things that might be worth adding in your own project. And it'll be a great way for you to learn React if you don't already know it, to flex your front-end skills, to flex your algorithm skills. So great project overall. I really hope that you enjoyed this video. I hope that this ended up being a good tutorial. I know that it was kind of weird because I was just rebuilding this project myself. I actually had kind of fun doing it. Let me know what you thought about it in the comments below. Like I said before, please don't forget to smash the like button, and I will see you in the next video.